All right, good afternoon. It is Tuesday, I'm pretty sure, November 17th. It is Tuesday, November 17th. We're going to continue our discussion of descriptive statistics. Before we get started, are there any administrative questions for me? Yeah. So the question is the written part of the second exam going to be curved because the average was so low? I have not looked at that. I'm meeting with my TAs this afternoon. I doubt it. We don't usually curve the grades in this class. You can drop your lowest grade. If you were unhappy with your performance, then take the final and drop your lowest exam grade. Oh, it's out of 20, not out of 100. Okay, so the grade book needs to be adjusted so that 20 equals 100. Okay. We'll make sure we do that. And I bet you the average wasn't that low. Other administrative questions? Yes. I don't know. I will look at it. Okay, I can't answer that right now in front of 300 people without the gradebook open. I'm meeting with the TAs right after class. So that would make sense. That it was graded on 20 points and it was entered as points, not as percentages. Okay? So maybe if you guys are online, can you hide it right now so that they don't freak out? But we will have that sorted out today. Have you been doing your research participation points? Yes, are you done with them? They need to be done by the last day of quarter. Okay, if your clicker scores are all 0, then email me your clicker ID and I will match you up with your performance. Okay? Yes? True. Clicker scores, I'm behind on updating the clicker scores. Okay? All right. So we have been talking about descriptive statistics, yes? We were filling out this form. Do you remember? Yes. Have you been filling that out as well? So we've been talking about our descriptive statistics, and we've been saying that your choice of descriptive statistics is entirely driven by whether you measured your predictor variable categorically or continuously, and whether you measured your outcome variable categorically or continuously, and that you just need to follow along and figure out which descriptive statistic goes with the way you've measured those variables. Now that's putting together 2 steps, and I'm always surprised at how difficult that is. You've been practicing, is this continuous or categorical all quarter? So when I start asking you, if I'm going to compare gender measured in 2 categories and the score on the midterm out of 20%, which would I be looking at? What row would I be on? What would be my predictor variable? Categorical. And what would be my outcome variable? Continuous. And so I'd be looking at the means and the standard deviations, right? I'd be looking at the average performance on that test. So don't forget your practice on categorical and continuous. We talked about calculating means and standard deviations. We talked about calculating the median and the interquartile range. You've looked at your homework, right? it's due on Monday, and you need to be calculating means and standard deviation, everything I ask you to do on homework, I'm going to ask you to do on the exam. On the exam, you will need to be calculating means and standard deviations of little groups, like we've done in the homework. I believe it's part of the multiple choice portion, and the answers aren't like 2, 3 decimal places accuracy. It sort of is the answer 1 or 2 or 3 or 4. So it's not, you don't have to be incredibly accurate and precise, but you need to understand what those formulas are, and you need to be able to reproduce them. Yeah. Oh, did I not post the podcast from Thursday? Okay, I will, I'll get onto that. Thank you. Yes? You may bring a simple calculator or a scientific calculator. Do not bring a graphing calculator, because graphing calculators do it for you, where you enter the data and it just tells you. And the point of this is that these calculations aren't that difficult, and you need to own them and you need to understand what they are. So please feel free to bring a simple or a scientific calculator, not a graphing calculator. It will be small groups, just demonstrating that you understand what is the measure of central tendency and what is the measure of variability, mean and standard deviation. Yeah. Yep. All right. Yes. Exam viewings? Yeah, there was an email about that today. I think they're this afternoon or tomorrow and Thursday and tomorrow and Thursday. All right. Let's take a look. So we got through all of the notes, right? We got through all of the notes on that initial lecture of descriptive statistics. So I want to go back and review some of that with your trolley data. Remember, we gathered data on your decision to save 5 cartoons or not, based on, hello? All right, so here's some of the data that we gathered. And what are we looking at here? So this is raw data. This is what we gathered the other day. I've hidden your names, but you can kind of see the first couple of letters of your names. What does this mean? What was that variable? Okay, so that was one of our main predictor variables, was whether you were in very close proximity to somebody, you had to push them, or if you were further proximity where you had to flip the switch. And then this was whether or not you chose to save 5, and that was on a scale of 1 to 5. With 1 was, I definitely would not save those 5 people, and 5 was, I definitely would save those 5 cartoons. Yes? And then the last question we asked was that sort of moral locus of whether you were raised to be good because there was like a higher power that had made the rules and was watching you, or whether you were raised to be good because it's good to be good. So kind of that, and that was on a 1 to 10 scale, wasn't it? All right, so you see that data. We've got some questions we want to ask about it, right? What do you want to know about this data? What question can this data answer? So the means, you want to know, well, so let me show you the whole distribution of whether or not you chose to save 5 people. So this is the histogram of whether or not you chose to save 5 people. Oh, sorry, that 5 should be over here. So it went from definitely not to definitely. What's this showing you? What do these bars represent? So the probability, the frequency of the whole group of 221 people, what's that, about 10 said 1. And about, what is that, about 35 said 2. So each one of you is taking up space on one of these columns. You can imagine it as sort of, if each one of you had put a little counter on there. What was the most frequent score? Response? 4. You can see that very easily. Does this look normally distributed? We talked about a normal distribution last week. What did we say a normal distribution looks like? So it looks like a bell curve. It looks very symmetrical. What do you think? It's not very symmetrical, is it? There's more people kind of clustered up here at 4 and 5, but then there's this asymmetrical tail going down towards the lower numbers. So I think that you're right that we would find that this was a negatively skewed distribution, that it is not entirely symmetrical around the mean or the measure of central tendency. But that's not really, well, here, let me tell you the histogram of the other outcome variable. So that the locus of morality, 1 was entirely external, and then 10 was entirely internal. And here's the values on that. Does that look normally distributed? No, again, it looks quite skewed, doesn't it? And people like the odd numbers more than the even numbers. So that's the overall histogram for the two groups. For the whole group. This is a continuous predictor variable, locus of control, the locus of morality. The outcome was also continuous. Therefore, to decide if those two things are related, we would calculate a correlation coefficient. Remember we talked about those last week or 2 weeks ago? When I calculated the correlation coefficient for locus of morality to decision, the coefficient was 0.03. Do you remember? Is that a number that gets us excited, or is that a number that makes us sad? That makes us sad, right? Because it means that there's no relationship. There's no evidence that there's any relationship between these two variables. Do you remember what we wanted our p-value to be? Less than 0.05. Yeah, no, it's nowhere near less than 0.05. So this would say there's no evidence that there's a correlation here. There's no evidence that these two things are related to each other. But that's not what you really want me to say. You, I hope, are itching to know, did the proximity make a difference? Is that what you want to know? Is there a difference between the people who were close and the people who were far on whether or not they were going to save the 5 people? In order to look at that, we would need to start by sorting the data by proximity. So we've got everyone who said close and everyone who said far away together. We want to calculate the mean and standard deviation. So let me just hide that morality locus. So we want the mean and the standard deviation of these numbers here. Now, Excel can do this for us very, very easily. And I am sure that from now on, you guys will have access to powerful statistics programs that will allow you to, that will just spit out these numbers. What I want to focus on is just making sure that you're understanding what the numbers mean, not so much on how, a little bit on how to calculate them, where they came from. But I understand that you are living in a blessed time where you don't have to hand calculate any statistics ever again. But for now, we will be doing some calculations. So if we want to calculate the average or the mean, what would be the first step to calculate the mean for the proximity group? Add them all up, all right? So I'm going to use Excel to add up all of the people in the close group. And then what do I need to do? Divide it by the number that is in that group. There are 125 in that group. Do you see how I'm seeing that? No. Let me count them. And then the average is the sum of them divided by the count. Yes? So for the group in close proximity, on average, 3.096 was the whether or not you're going to save 5 people. Now that we have the average, we can go through and calculate the standard deviation. What's the first step in calculating the standard deviation? X minus the mean. All right, so is that score minus the mean? I'm going to fill that down for all of the scores. Now on your homework, you've got like groups of 10, so it's really easy to do it by hand. But I recommend that you go through these steps and you figure it out. You understand what you're doing. What's the next step in calculating the standard deviation? Square it, that number times itself. I'm going to fill that down for all of the people in that group. What's the next step in calculating the standard deviation? So I need to sum that up, don't I? So I need to add up those numbers. So I've added up those numbers. What's the next step? Divide by n minus 1. N is 125, so I'm going to divide by 124. What's the last step? Square root of that number. There we go. Our standard deviation for this group is 1.22. Excel will do it for you. We use the same formula that Excel is using. Do you see that they did it for us? We got the same number. So those are the steps. The difference between each score and the mean, squared, divided by n minus 1, and then unsquared. So let me show you some of that, comparing those two groups. Because I did it for you. Here's one I prepared earlier. So for the close, I had removed some of the people. The N doesn't look exactly the same as it just did because I had removed some of the people who didn't respond to the last question. So this is a subgroup. So here's the histogram for the close proximity, the mean, median, mode, standard deviation. Here is the histogram for the far proximity. Do those look the same? So in the far, what do you think the mean is here? It's got to be around 4, right? Because it's, everyone's clustered between 4 and 5, with very few people saying 1, 2, and 3. Whereas for you have to push the guy over the bridge. Well, we just calculated, right? The mean was right around 3. And you can absolutely see that that's where you would expect the mean to be. And this actually looks a lot more symmetrical, doesn't it? And so, indeed, the mean for the far proximity is 3.9, close to 4, with a standard deviation of 0.9. So we've got the two means. Next week, we'll start talking about, next week I have to let you go home for Thanksgiving. The week after next, we'll start talking about how we, actually no, maybe it was next week. We start talking about how we decide that this is a big enough difference to be confident and say, in this case, this group answering a mean of 3 and that group answering a mean of 4 is different, that our manipulation of the information you gave made a difference. So we had categorical predictor variable measured in groups. We had continuous outcome variable, and we calculated the means and the standard deviations of those two groups. And we would then compare those two. Questions about calculating those descriptive statistics? Yeah. Okay, so the question is about that. How do we make that decision of are these groups different? And we're going to build up to it, promise, if you're going to keep seeing the data. We will need to calculate an inferential statistic and look at whether that tells us if it's a real difference or if it's, just chance error. And that's where we're going in the next, starting Thursday. All right. What if our predictor variable was categorical and our outcome variable was also categorical? So we said, that the 1, 2, 3, 4, 5 response definitely to definitely not is continuous. But we could certainly say they would save the person, or they wouldn't save. They would save 5, or they wouldn't save 5. We could kind of dumb it down into they said no, or they said yes. And if I do that, then this is what that data that now looks like. So I've got a categorical predictor variable, what was the proximity, and now I have taken my outcome variable and made it categories as well. Did they say, yeah, they'd save the 5, or did they say, no, they're not going to save the 5? What do those numbers mean? What's the 33? What's the 32? What's the 43? What are those? The number of people responding in each of those groups. So it's the count of, there were 32 of you in the close group who said no, 1 or 2. What would we need to do in order to summarize this data? Percentages, right. We would need to add those up and then say of the group that were in close proximity, what percentage overall said no, or overall said maybe, or overall said yes. one more thing in this proximity data. I hid one of the columns, right? I hid the morality locus. What would that be, a predictor variable or an outcome variable? Predictor, right? So we gathered 3 variables here, whether you were in close proximity or far proximity. Well, your locus of morality is, and whether or not you would decide to save those 5. 2 of those are predictor variables. 1 of those is an outcome variable. What's that design called when we have more than 1 predictor variable? A factorial design, where we've got more than 1 predictor variable. And we don't just look at the, well, we've got more to look at when we've got more than 1 predictor variable, right? So we need to know so we've got the predictor variable of were you in the close group or the far group.